about hydration reactions, and we were talking about how to get alcohols across a double bond, starting with an alkene. And let's review that reaction by reviewing one example. So as you know, we start with an alkene as usual in this chapter, and that will get protonated because we have the acid here. So the first step is going to get the nucleophile attacking the acid, and we can potentially get two possible carbocations. So the backbone is going to be the same one, but if the um, H goes in that side of the double bond, we will get the carbocation there. That's a secondary carbocation. Or if we get the hydrogen to go on this side, we will get the carbocation there, and that's a tertiary carbocation. Remember that carbocations are more stable the more substituted they are, so the tertiary is the carbocation that is going to form. Now, in the first step, water left, so now water can act as a nucleophile and come and attack that carbocation. What we will get is the water there. And now the last step is that another molecule of water, we have a lot of molecules of water because water is our solvent. Now it can come and take away that extra hydrogen, so we can end up with a molecule that is neutral. And I forgot one carbon there, so let's just put it. And this is the alcohol that we will get. But there's a potential problem with this. Because we go through a carbocation, and we've seen this with elimination reactions and SN, so E1 and SN1 reactions, we can potentially get rearrangements. And when we work in a lab, we want some type of reassurance of what are the products that we're going to get. When we start getting rearrangements, what happens is that we start getting mixtures of products, and the reactions become complicated. So chemists have come up with other ways of getting an alcohol in a double bond, or add an alcohol to the double bond. And those two methods are the oxymercuration and the hydroboration. The first one, the oxymercuration, we will see it in a separate video, but what we get is the Markovnikov product form, just as we saw using acid. And we will get an anti-addition. So that means that the H will come from one side and the OH will come from the other side. And the great thing is that we will get no rearrangements, and that's what we really want. For the hydroboration, we will get the anti-Markovnikov product, which means that it's going to go to the less substituted carbon in the alkene. The OH is going to go to the less substituted carbon, and that we will get a syn addition because the H and the OH are going to come from the same side. Let's talk about those two in separate videos.